Good morning, good afternoon, good evening. My name is Andrzej Wodecki, and I'm gonna be a teacher on the course on architectures and implementation methodologies of artificial intelligence. For more than 10 years, I specialize in AI. At the moment, I do research on generative AI, and I also implement such technologies in mid and large corporations. So I hope this course will also be a chance for me to share my experiences with you. And I hope you will enjoy the way I'm gonna help you to develop your skills on making your AI models happen in reality, deployed and maintained in the production environments. So before we delve into the course outline, let's have a look at something very simple. Just look at this code and for a few seconds contemplate what's happening here. Okay, so let's have a look at this together. As you can see at the very top, we have some basic imports. We import pandas, NumPy libraries. Then we have some CSV file read into the data frame. Next, we import some libraries which help us to generate, train and test data sets. We have some features definitions. We create a training data set with X as a set of features and Y as an explanatory variable we would like to predict. And that's a simple regression model. Then we also have the same done for test file. We import a linear regression model from scikit-learn library, and as you can see, this single line generates a trained model for us. And finally, having that model trained, we take test dataset and make predictions on this dataset. And at the final step, we evaluate this model. So we import some libraries for mean squared error evaluation and compute root mean squared error variable printed out on the screen. And finally, as you can see, we import some pickle serialization library and save our model to the hard drive. So as you can see, it's possible to go through the whole process in just few lines of code. And now, that's probably you know from other courses on machine learning fundamentals, for example, nothing fancy here. But now let's think about what may happen during the journey to production. Okay, so what may happen in the process when we want to deploy this model in our servers and help users to use that model in practice, for example, our business users or final customers. Let's think about this. So I hope you spend some time on this contemplation, and I will come back to you now. Firstly, what may happen? Firstly, this data source, as you can see now, is just a file on our hard drive. In reality, that will be firstly, not only a single file, but maybe multiple files if we cope with big data, or that may be a database, or maybe some Hadoop file system for big data analysis. Okay, so the source of data may change. The types of data, the source, whether it's a data lake or database or the set of files, thousands, millions of files. The next thing which may happen is that these features are not computed for us and given to us, so we probably spend many hours on so-called data cleaning, feature engineering, data preparation, and all that stuff. Next, something more might happen in this line. At the moment we are using a single model. but we may be interested in different data science experiments with different models, or just use auto machine learning libraries, auto ML libraries, ask some other libraries to choose the best model for us, and then fine-tune the hyperparameters for us. Finally, when we make those predictions, obviously we would like to deploy this model to the production, and next allow our customers to make the prediction using different endpoints, whether it's a website or some API or a mobile app or something integrated with business intelligence systems we have at hand, whatever. So as you can see, that a picture may be, and reality will be for sure much more complicated. This is the idea for this course, and if we follow the research made by Google many years ago, they have found that this machine learning code we developed during the data science process is just a tiny piece of all the effort made by not only data scientists but also data engineers, machine learning engineers, and other people in the team. So we have other different activities like configuration of the system, automation of those processes, data collection processes, data verification processes, feature engineering, testing and debugging, not only of the model but also of all the infrastructure we have at hand. Next, we have resource management like servers management, etc., model analysis, process management, metadata management, serving infrastructure, monitoring, etc. So sometimes you may have feeling that data science part, the string part, is a key part of your project. In fact, it may be just only 5% of the total time spent on the whole machine learning project, from the first idea, the happy customer using this model in its reality. So that's the motivation for this course. And since we are going to talk about artificial intelligence systems architectures, so next question to you, let's think about what does the good architecture mean to you. Just think for a second. What does the good architecture mean? Good building. Imagine that you have a good building. Obviously, the answer depends on you, on your experience, on your needs. For me personally, a good building is a building which serves its main purpose. As the potential house owner, I have a dream that I will have a flat or maybe a small house for me and my family, which is somewhere in the forest. Yes, it needs to be not only nice, but also not only good looking, but also be a part of all the environment. For the most important thing, it needs to be functional, secure, safe, etc. But on the other hand, I need also to take into account that my life is gonna change. So at the moment I might have, for example, 5 to 6 persons in the family, but after some time my kids may leave me, so I will be here with only my wife. So we need to also take into account the change in time, yes, scalability, maybe some also evolution of the technologies we have at hand, for example, for energy consumption and energy storage. So that what we expect from such a building is it needs to be flexible for the future, so-called future-proof, but on the other hand, not overbuilt. So if I need something very small now, I'll start with something small. Yeah. So the same obviously is valid for IT architectures, specifically machine learning or artificial intelligence architectures. So when we have for a typical data science project, we have three roles. First one is the system architect, someone who will design the system at the very top level. Next, we have a data scientist, someone who will be responsible for data science part. So just simply feature engineering, model training and evaluation, hyperparameter fine-tuning, yes? And we also need a machine learning engineer who will take this trained model to the production and deploy it. In the meantime, obviously, we have also data engineer, but we'll cover this topic later on. And from my personal experience, when I look at the time spent during such a typical project for system architect is a 50%, and data scientist, paradoxically, is not the time-consuming part nowadays, and machine learning engineer is just that. So as you can see, system architect, someone who is responsible for not only the design of the machine learning outlook, architecture, but also in integration of those systems with some other systems is a key person. So now let's have a look at the course outline. I have divided this course into the following parts. Firstly, core processes, next fine-tuning, operationalization, and automation of all the processes. So that resembles the typical phases, stages in model training and deployment reality. So in that part, we are going to talk about machine learning model lifecycle, modularization, and machine learning pipelines, extremely important concepts nowadays. Next, since during the training stage, we need to experiment with different algorithms, different hyperparameter sets. There are a lot of different new technologies coming each week. So we need to have another topic on fine-tuning. So we are going to cover experiment tracking techniques, but also very important concepts like model drift, which stands for the natural change of the model. Reality is changing, so after some time our models may simply lose its accuracy or other parameters of efficiency and quality. So that's what we call model drift or data drift or combined. Next, in this part devoted to fine-tuning, we're going to cover also auto machine learning model systems. Next come the most important part of our course, operationalization, so architecture design, deployment scenarios, infrastructure management, data and model versioning, and containerization with elements of Docker and Kubernetes. And finally, we cover topics on machine learning operations, fundamentals, MLOps level 1 and 2. Those two things will be a part of this. So for example, when I'm gonna cover machine learning pipelines, natural way I will use experiment tracking, model drift, or AutoML model drift, and that AutoML will also connected with MLOps. So they are interconnected things, but you'll see it in practice later. Now let's go to labs. At the end of the course, I expect that you will be able to create by you, or preferably in small teams, some project which shows that you are capable to deploy the machine learning model in the production. So I suggest you to work in the following epics and sprints, if I can borrow some terms from agile methodologies. So firstly, very important part, organization. So I suggest you to form teams, and for each team create some environment like shared docs or GitHub or something to manage the project. Next stage is a baseline model implemented as a pipeline deployed online. So your goal would be to select the problem next. And this is, by the way, a very important part, which is quite difficult for students, as I observe. I will mention it in a second. And then take the selected problem and implement it. Is just very easily in Jupyter Notebook and deploy it online. Deploy online, for example, Colab notebook, yeah, Google Colab. Next, to refactor this code into Python modules and place in selected folders. That we are going to have a very simple lecture on this later on. And finally, project implemented as machine learning pipeline, which is, by the way, quite difficult using Kedro. Okay, so next we'll have machine learning pipeline enabling model refinement. So we add some extra flavors to our machine learning pipeline. So add the flavor like experiment tracking or train the model with auto machine learning systems and identify optimal features, algorithms, and hyperparameters. So, by the way, with AutoML it's very easy. That's a bit technical, but I hope you can cope with that, for example, using weights and biases. Next, we'll implement such a machine learning pipeline in the production. Okay, so I think that's the most interesting part. And then, if you have time and energy for some extra activities to make your project outstanding, I would like you to implement model stores or CI/CD pipeline for your project. I say or because that's quite challenging, and if you want to really learn something practical, but as I said, depending on your technical skills, that may be or may be not difficult. So that's why I encourage you to form teams where you have on one hand some data science experts, on the other hand some maybe very good programmers who have some experience in cloud computing, for example. And next, finally, make some documentation of the project and send me some final presentations, whether it's a PowerPoint or what I prefer is a short video showing you showing off your final product, for example, on YouTube. So that's for labs. So once again, I suggest to work in teams because there are a lot of things to do and go through this project step by step. Recommended tech stack. It's a huge topic, but let me recommend you some my favorite technologies which may be used during the course. Firstly, I strongly suggest you to work on Ubuntu or macOS or some other version of macOS that may be Sonoma, whatever. From my experience, I found those systems the best for deploying machine learning projects. They are simply Linux based. I do not have the experience on Windows. I tried it many times, but to the best of my knowledge, best systems for machine learning are Ubuntu and macOS. macOS obviously for local deployment. If you want to deploy this on the cloud, it will be on Linux. In Microsoft, yes, you can use Windows subsystem Linux 2 to simulate Linux. That's also possible. For IDE, for integrated development environment, I personally use Microsoft Visual Studio Code, although I work on a Mac ecosystem. That's for me definitely the best solution. Plus Copilot from Google, which helps me a lot in my coding. For code versioning, obviously GitHub or GitLab, whatever Git technology you choose. For virtual env, I strongly suggest you to use Miniconda, not Anaconda, but Miniconda to manage virtual environments. Obviously, there are some other options like Poetry, which becomes more and more popular nowadays due to its efficiency in Docker container deployment. Later on, we are going to slightly touch this, but still, at the moment for this course, I suggest you to use Conda for managing your environments. For machine learning pipelines, I'm gonna use Kedro. So this is a system which enables you to create pipeline in Python and then visualize it and deploy it in different forms later on. You can also use MLflow for pipelining, but it's still not that major, in my personal opinion, than compared to Kedro. It has some MLflow pipelines. It's still an experimental form, but if you are experienced with MLflow, that's obviously also another possibility. For experiment tracking, you have plenty of different solutions. You have Neptune AI, you have MLflow tracking, and it looks like that. Its benefit is it's open source, it's free, you can install it either on your server, on your computer locally, and this is the very good benefit in case you would like to work with some sensitive data. For my course, I decided to use weights and biases, which is paradoxally, you may think that it's not good, since firstly it's commercial, secondly it's hosted in the cloud, but I decided to use weights by biases, firstly because it has a very nice free tier, so in case you would like to make your own experiment tracking without paying, it's possible, and secondly extremely easy to use, and very powerful because at the moment they do their best to become full MLOps platform, and especially if you are students, that might be very easy for you to track not only machine learning experiment but an IT experiment with the tool, including generative AI, and create beautiful plots, graphs, documents for your diplomas. So we're going to use weights and biases. Just a quit for a second from open source solutions. So as you can see, this is the sample project. You not only track in those projects your computer resources consumption, but you can also make hyperparameter optimization. That's gonna be one of the topics we're gonna cover. And for AutoML libraries, if you would like to learn AutoML, PyCaret is definitely the greatest choice, one of the best choices, but in the real application, my favorite choice, obviously I'm talking about my experiences, is AutoGluon from Amazon. AutoGluon Tabular maybe does not look that nice, but believe me, it's extremely popular. It has very tricky options which help you to really work with large machine learning projects on production. So that's open source. Both are open source. If you would like to use some tool for fine-tuning, it's an open library, up to now one of the best libraries of the type. It's being integrated into other systems like weights and biases, for example. So if you have some projects where tuning the hyperparameter of your model is key, I think that you should give it a try. And Hydra, another very interesting tool which enables you to control the parameters of your models directly from the command line of the shell script. So this is very important for machine learning operations, because in such projects we need to do everything to take all the parameters of your runtime for your Python code from outside of the Python. Yes, and Hydra is I think very smart tool for that. For data versioning, I suggest to use data version control, very interesting library, which at the moment went into also almost whole machine learning ops library. We also talk about what does data version control mean later on. So, and for model versioning, because obviously data is not the only thing, but look, we have the following objects in our project. We have a code which we typically version. Yes, we have GitHub for that. For data, yeah, it's not that popular to version the data, but if you work with large data sets, like for computer vision training, it appears that just keeping different versions of your data on GitHub is not the best solution because it consumes a lot of memory. So there is a need for data versioning. But for model versioning, we have the same. We may have many different versions of the model during the initial training, but later on, during the model retraining, because, for example, the data drift, we need to also version models. So for the whole ecosystem, I'm gonna use Google Computing Platform, GCP, Google Machine Learning environments. And we'll slightly touch, obviously, this is the whole overview of that infrastructure. We have a lot of systems, okay, so we don't have time to cover all those things, like dedicated system for data ingestion, data processing, data warehousing, databases, data storage in general, okay, so machine learning, etc. If you're interested in that stack, I strongly recommend you to, if you didn't do it previously, to go for its great courses on this topic. They have at the moment a very interesting framework named Vertex AI, and we are going also to use that in our course. Specifically, there is an open source library which you can install on your computer, Google TensorFlow Extended, and we are going to use it only for data validation. Okay, we are going to have at least one large lecture on data validation because that's a key part of machine learning pipeline nowadays. For continuous integration, if we touch it, we won't probably go into details of that, but one of the most common ways to deploy it are simply GitHub Actions. So if some of you is familiar with that, you know it, or if not, I suggest you to look at this technology. For containerization, obviously Docker, or on the top level, Kubernetes. It's not for containers, it's just operating system. For clusters, we are also going to have a separate short lecture on the basic concepts of Kubernetes. Different flavors of Kubernetes, like Kubernetes in Docker or some other options. On top of Kubernetes, on top of Docker containers, you also may run a pipeline. So when you compare the Kedro to Kubeflow, Kedro is a pipelining tool which may be run on a single server. Kubeflow is the same, but for containers deployed on different servers. So imagine that you have a pipeline which has different artifacts and different components. Components are objects like programs or Python scripts or containers which do some job. Yeah? So Kubeflow may help you to manage such a pipeline in a situation where those components are Docker containers running on different servers managed by Kubernetes. So we'll also touch this concept shortly. Okay, so prerequisites and learning resources just to complete my course. You have some website in Polish, Wodecki GitHub.io. Obviously, I will give you now my course materials. If you want to learn Python, I strongly suggest to learn Python from this book, but I assume that for this course you have some basic knowledge of Python. If you'd like to learn Python or machine learning, this is my favorite choice, Become a Data Scientist path from DataQuest, or Introduction to Python Programming from Udacity, a great free course. We have some other free courses on GitHub there on Udacity. And for the full machine learning operations courses, I recommend you this specialization on Coursera. Deep Learning AI is owned or managed by Andrzej Wodecki, which you can see him here, one of the best, in my personal opinion, people in the world of AI, and his specialization on machine learning engineering is also deployed on Coursera, so this is probably not the best ways to learn this topic. This is also a great machine learning DevOps engineer specialization on the degree program on Udacity. It's quite expensive, but as you can see here on the top right, you might get some personalized discount, and if money is not the issue for you, that would be my first suggestion. Extremely practical course on the topics covered in this course. Yes, so I was inspired by this course in my lecture. There are also a lot of very good resources on machine learning and AI in general on Google Cloud trainings, specifically on machine learning DevOps. For Docker basics, if you are not familiar, the best, definitely the best from my personal opinion is this Docker Hub Quick Start, which is visible here, and quite well explained on my course materials. I'm gonna share some courses with you in this lecture. On Kubernetes, if you would like to get familiar and get some basics, this is a course on MLOps Machine Learning Foundation Operations Fundamentals on Google with some very good introduction to Kubernetes. Inspirations for a project. This is very, very important part of this lecture. Where's the hack? Important thing. This course is not about machine learning training. So I strongly suggest you to use a very toy example for a project. Avoid deep learning training. Why? Because for your case, you need something which is possible to be trained in less than a minute, or preferably in 15 seconds. Why? Because you perform a lot of different iterations of training. So I know from my previous lectures that students try to spend a lot of time on the very ambitious machine learning project. So it's not that course, okay? That course is just on taking the trained model and deploy it. So, okay, that's enough. Where to find those inspirations? Firstly, there are a lot of very interesting tutorials on Picard on segmentation, classification, regression, whatever. If you do not have some idea on what to choose, take this example. It's fast and easy. So as you can see, you have tutorials on binary classification, multi-class classification, regression, time series forecasting, clustering, anomaly detection. Believe me, that's enough. That's enough, okay? There are also some good tutorials on AutoGluon. Maybe it would be good for you to start with that. Go through this tutorial. It's quite easy, quite fast. It has a very good examples, and take one of those examples for this course as a project, okay? So once again, avoid ambitious machine learning projects, ambitious in the sense of the data science part, okay? It needs to be easy and fast. Obviously, you will find a lot of different inspirations. For example, on medium.com, which is my favorite source of knowledge for data science. This is my main site, okay? That's my home site. This is the site I start my day with. But there is a risk that you will find something too ambitious here, okay? So as I said, tutorials, some other tutorials like Kedro. Kedro has also very good tutorials, or DVC has very good tutorials. MLflow has a very good tutorial, so you might also choose those topics there. There is also a very interesting repo on GitHub from Google Cloud Platform Training Data Analyst. They have, as you can see, a lot of different courses here. You can go for these courses and find some examples, but besides speaking, they are quite difficult in some cases because they choose those examples very carefully, and if you find some example which is used in the course on big data, that may be too difficult for this course. Okay, so that's another repo on MLOps on GCP that may be a bit better dedicated to you, but believe me, it's quite difficult still. Also have my repo where I store different business machine learning projects, so you can also consult this site for inspirations. Okay, and a few words about the organization. I'm gonna share those files with you on Microsoft Teams. For project management, I really encourage you to start with very careful planning, not to choose something too difficult, and work in groups. When you form a group, it's good to have different people with different skill sets, specifically to have some good engineer who knows how to code, who knows basics of fundamentals of cloud computing. A data scientist is someone who is familiar with model training, model evaluation, and system architect who will manage the project, yes. You may use different tools for project management, something like Asana, Trello. Think about that, because planning skills and project management skills are as much important as technical ones, sometimes even more. So I think that this course will be also a vehicle for you to develop skills like that. There are plenty of tools like that. You may use ClickUp, Trello, Asana, Basecamp, Jira, Shortcut, whatever you use, or just a shared Google spreadsheet, whatever you want. Communication with me, email please. Okay, this is my email. It's very hard for me to answer Microsoft Teams messages because of many reasons. The most important is that I completely do not use social media, and opening communication platform is really tough. So if I can only ask you, please contact me with my email. Okay, so that's all for this lecture. I hope you got inspired, and see you on next one. Thank you very much. Enjoy.